Hi everybody and welcome to this video. In this video, we're having a look at the 2020 Prelim question 2. So the question 2 is on the regression. So you're going to need your calculator for this question and it's quite simple from there. So let us have a look at the question. So it says a question raised by many educators is whether the results that a learner achieves in the examination is independent on the time that the learner takes to complete the examination. The average time taken for each of the top 10 mathematics learners were recorded. The data is represented in the scatter plot, in the table and scatter plot below. So here we've got the data. So we've got the average time, and that's our x coordinates, and then the learner's marks, which are our y coordinates. The one on the x is also referred to as the independent variable, and the one on the y-axis is referred to as our dependent variable. Please remember that because they could also ask it to you in that form. So the first question says calculate the equation of least squares for the data. So that's 2.1. The equation of least squares follows a straight line. So a straight line equation where it's a plus bx. To get the equation of the least squares, you're going to use your calculator. So first of all, you set your calculator into the stats mode, and then you choose the option for the linear regression one. So the one where it has the formula y is equal to a plus bx. In the place of x, you fill in the average time, and in the place of y, you fill in the corresponding learner marks. Once you have that, you can then go back to the stats mode and find out what is A and B. So using your calculator, we get that A is 12.41 rounded off to 2 decimals, and B is 0.49 rounded off to 2 decimal places. Therefore, your equation is 12.41 plus 0.49x. So our estimate of y is equal to that. Okay, so that is quite straightforward, and this section is generally quite easy, providing you know how to use your calculator to calculate it. Okay, so then it says a learner completed the exam in 2.5 hours. Predict the mark that they achieved. So what goes in the x coordinate is the time in minutes. So first of all, those 2 hours, we just are going 2.5 hours actually. We're going to just have to convert to minutes. So 2.5 hours is 150 minutes. So now we can substitute it into our regression line. So y is equal to 12.41 plus 0.49 times 150. Typing that into your calculator, we get 85.91%. Okay, so then 2.3 says explain within the context of the regression line why it is not reliable. So if we look at our regression line, we have y is equal to 12.41 plus 0.49x. Now, one of the things we can look at is maybe the y-intercept. So the y-intercept is 12.41. That's saying if somebody takes 0 time, they will get a score of 12.1. So if somebody takes 0 minutes, they will get a score of 12.1, and that's not realistic. It is not realistic to spend 0 minutes and get 12.41%. Okay, so then having a look at the next question, says calculate the standard deviation of the top 10 mathematics learners. So once again, this here is more based on your calculator than anything else. So you enter your learners' marks into the data of your stats. You then opt to choose for your standard deviation. So calculating a standard deviation, we get that it's 10.28. So this is using the calculator. Obviously, you can use not the stats option, you can also use the definition of the standard deviation to calculate it. However, that will take you much longer. Okay, so then 2.5 says, given that P and 103,59 is the interval of 15 random marks within one standard deviation of the mean, and X bar is equal to 63.96, you have to calculate the P. Okay, so within one standard deviation means that this P corresponds to our X bar minus a standard deviation, and this one here corresponds to X bar plus our standard deviation. So we know our X bar is 63.96 minus sigma will give you P, and 63.96 plus sigma will give you 103.59. So what we can do is we can use this side over here to solve for sigma. So we have that 103.59 is equal to 63.96 plus sigma. So solving for sigma, we get that it's equal to 39.63. Then we can substitute it back in here. P is equal to 63.96 minus sigma, which we now know is 39.63. So then what we can get for P is 24.33. So this question here depended on you knowing what does it mean to be within one standard deviation of the mean. Okay, so please make sure you review your regression and how to do these calculations on your calculator. It saves you a lot of time and makes the section quite easy. Thank you for watching, and please watch our other series on this paper. Bye.